Ooh, a present. Dear Tim and Moby, how do we know what atoms look like if we can't see them? From Darren. Yeah, atoms are small, real small, too small to be seen. Still, scientists can do experiments that tell them things about what makes up an atom. Right you are, my robot pal. You can't see what's inside the box, but shaking it can give you clues as to what's inside. It's the same with atoms. Using indirect means, scientists have been able to construct different models of the atom. This atomic model has taken years and years to build, and people still tweak it now and then, hopefully making it more and more accurate. Let's take a trip through time! At the beginning of the 19th century, Englishman John Dalton built an atomic model called the atomic theory of matter. Dalton's model was really just a set of ideas. According to his theory, each type of matter is made of only one type of atom. For example, gold atoms make gold, iron atoms make iron, and so on. These atoms were way too small to see. So far, so good. About 100 years after Dalton, J.J. Thomson discovered the electron. Thomson used a vacuum tube with metal plates at both ends and an electrical source for his experiment. He found that a beam would form between the two plates, the cathode and the anode. Putting a magnet near the beam caused it to bend, which meant that the particles of the beam were electrically charged. Thomson discovered that the cathode rays were made of negatively charged particles called electrons. Because matter is mostly neutral, with no net charge, atoms must contain both positive and negative charges that cancel each other out. Thomson stated that negatively charged electrons must be stuck all throughout a positive mass. Think of it like the atom is cookie dough and the electrons are chocolate chips. The discovery of electrons was a big deal, but it left some questions to be answered. What were the positive particles holding those electrons in place? In 1909, Ernest Rutherford and his team set out to answer some of those questions. They beamed positively charged alpha particles at a sheet of really thin gold foil. Because so many particles could pass right through the thin gold foil, Rutherford hypothesized that the gold atoms must mostly be made of empty space. But some of the particles did bounce off, so Rutherford revised his hypothesis to say that a gold atom must have some very small positively charged mass. He named this mass the nucleus. He called the positively charged nucleus particles protons, and said that the electrons were scattered in empty space around the nucleus. James Chadwick, a student of Rutherford's, found new particles in the nucleus that weren't affected by an electric field at all. Alpha particles in the experiment had knocked them loose. Chadwick called these uncharged particles neutrons. Also in the early 20th century, scientists discovered that electrons are arranged in energy levels. The lower energy levels are closer to the nucleus and can hold just a few electrons. The higher energy levels are farther away and can hold more electrons. Electrons are so small and quick that their energy levels are not neat planet-like orbits around the nucleus. Instead, they exist in a region called the electron cloud. The atomic model is constantly evolving as scientists discover more and more about what makes the universe tick. Oh, okay. Go ahead and open it. Hey, it's an atomic model. Well, you have to put it together. That's not right.